All right, hello students. As you can see, I'm sitting here at the house. It's a cold Saturday morning. I woke up and my heat was broken. So it dropped down to 56 in the house last night. So I'm sitting here all bundled up. What better time to do a little math? Sorry that I'm not in class today. I am at my brother's wedding, probably helping him set up and getting ready to give my best man speech a little later tonight. But I want to help you with these trig equations. And I'm actually going to start on this page of the notes for this first video and keep this one around 12 minutes long. And then I'm going to jump to the second page of the notes on video 2, and that's the new part of the lesson. But I thought it might be worth reviewing some of these beginning notes. Okay, so we're solving equations, and as you can see here in these first two examples, there's one trig term there. This first example just has a sine of x. Let me underline it here, and the second example has a cosine. If you ever have just one trig term, then what you need to do is you need to isolate that trig term in the same way that you would isolate like the variable x when you're solving an equation. Like the trig term is the unknown. The trig term is the variable. So like you would all know what to do if this was the equation, right? 2x minus 1 equals 0. You would add 1 and then divide by 2. Same thing is here. Same thing is true here. We need to isolate the sine of x. So I'm going to add 1 to both sides, divide by 2, and I have sine of x equals 1/2. And this is where the unit circle comes back into play. We need to think of the two different angles. In this case, it's 2. As you'll see in the next video, it can be a lot. But what two angles would cause sine to equal 1/2? So we know if we think to our chart, sine of 1/2 is with a 30-degree reference angle. So one of the angles is pi over 6. And then when else is sine positive? It's positive in quadrant 2. So I need to think of whatever the other over 6 angle is in quadrant 2, and that is 5 pi over 6. So those are our two answers for this first one. Okay, let's do the same thing over here, but notice the cosine is squared, so our algebra is going to change just slightly. So we look, and we're going to add 1 to both sides, because my goal is to isolate the trig term. So I need to divide by 4. And then this cosine squared, that's just like an x squared. The way you deal with that is you square root it. So we have cosine of x equals plus or minus 1/2. Okay? So if over here on the left example, we had 2 answers, over here, we're going to have 4 answers because we're going to have the 2 that would deal with the positive 1/2 and the 2 that would deal with the negative 1/2. So I'm going to say that x is equal to, let's see, when is cosine 1/2? Well, sine was 1/2 at the 30-degree angles, so cosine is 1/2 with the 60-degree reference angles. And we just said we're going to have all 4 of them because it's going to deal with the positive quadrants and the negative quadrants. So that actually makes it a little easier because I know pi over 3, 60 will work. That will give me 1/2. I know that 2 pi over 3 gives me negative 1/2. 4 pi over 3 gives me negative 1/2. And 5 pi over 3 gives me positive. So there are our answers. And I should have done this on the left example too. I should have said that x equals this, because that's ultimately what we're finding. We are finding the angles that make this equation true. Okay, so that is the first section when there's just a single trig term. The second section is a little more involved, but compared to the proofs that you guys did last week, like the algebra is going to be right up your alley. You're prepared for this. If there's multiple trig terms, we need to look to factor. That's going to be the best way that we can manipulate the equation to where we can solve for x. So we're going to factor, and sometimes when you're to do that, you have to set things equal to 0. You want to move everything to one side of the equation, right? Like if you look at example 1, you can see that the equal sign is here and the terms are on either side. We need to move everything to the left and set it equal to 0 before we factor. And then on the right, same thing. We need to move this sine of x over here. And I'm going to go ahead and tell you this because this is the most missed thing on these equations, is that we want to do this. We want to divide by sine of x and cancel and have tangent of x equals 1. And that will give you 2 of the answers, but it will be an incomplete problem because you're missing out on a few other answers that would work. When you're solving trig equations, you don't want to cancel, because what we did is we kind of just took away some of our answers. We simplified it, but our answers for x are going to be incomplete. So what we would rather do instead is subtract this to the other side. So it would be sine of x tangent of x minus sine of x equals 0. And now we can pull out a GCF, okay, which we'll do that in a second. So if there are multiple trig terms, we want to factor and set it equal to 0. And then, let me just make sure I give you the right thing. Yeah, identities. Sometimes you gotta use identities to, in order for us to simplify and solve. So let's do a couple of these. Let's start with the one on the right, since I just kind of dove into it. We are going to subtract sine of x over. So I'm going to have sine tangent minus sine equals 0. I'm going to pull out a GCF. Both of these terms have a sine in them. So if I pull out the sine as my GCF, I'm left with a tangent minus 1. Okay? And now for important algebra concept. This is called the zero product property, the ZPP. When you have two things that are being multiplied together like this, I'll put 1 in that box and 1 in that box. To solve for x, we have to set up 2 different like mini equations with each one. We're going to set sine of x equal to 0 and solve, and we're going to set tangent of x minus 1 equal to 0, and we're going to solve. And that's where unit circle takes over. When is sine 0? Sine is 0 at 0 radians and at pi. So there's 2 of my answers. And then we need to solve this one. So I need to move that 1 over. When is tangent of x equal to 1? Unit circle. Tangent of is 1 at the 45s, right down the middle. So this must be 1 at pi over 4, 45 degrees. And when else is tangent positive in quadrant 3? So what's the over 4 in quadrant 3? That would be 5 pi over 4. So there are my 4 answers for this one. Okay? Hope you're tracking. All right. Now let's look at this one as a squared. First thing we need to do is we need to get it all on one side. So 2 sine squared of x minus cosine of x minus 2 equals 0. If you're wondering what I did, I just subtracted this over there and subtracted that over there. I got everything to one side. Okay, and now I'm looking, and something's not right here. This looks like 3 terms, 1, 2, 3, and so I should be able to do guess and check, but one's a sine, one's a cosine. That's not going to help us. We have to use an identity to convert everything to the same trig function. Okay, convert everything to the same trig function. That's worth kind of putting here. Convert to same trig function. So I am going to switch out this sine squared for a 1 minus cosine squared. Still have my minus cosine and my minus 2. And now let's do a little algebra from here, because now we've got 2 times 1 is 2. 2 times negative cosine is negative 2 cosine squared minus cosine minus 2 equals 0. I'm hunting now for things, what's going to cancel, what's going to simplify. I see that this 2 and this negative 2 cancel. And so at this point, I am left with a negative 2 cosine squared. Whoops. My forearm just turned on the hotkeys. Negative 2 cosine squared minus cosine of x equals 0. So now we got everything in cosine form. We're ready to factor. And what can we pull out? We can pull out a negative 1 and a cosine. So let's pull out a negative cosine. And that leaves behind a 2 cosine? Wait, not squared, just a 2 cosine. Plus 1? Let me make sure that works. Negative cosine times this. Yep, that's it. And then negative cosine. Okay, so there, we factored correctly. And now same thing we did over here. ZPP, zero product property. So we're going to go 1, 2. Those are going to be our two little mini equations. So we're going to set negative cosine x equal to 0 and solve that. And then we're going to set 2 cosine of x plus 1 equal to 0 and solve that. What is my time limit at? I can't see, so let's just finish this up here in the next 30 seconds to make sure that we're good. So when is cosine 0? Well, negative cosine, you can divide both sides by a -1, and that negative just goes away. There's no such thing as -0. So when is cosine 0? That is, cosine is 0 at 90 degrees and at 270 degrees. So there's 2 of my answers. And then 2 cosine plus 1. Oh, we just need to add 1, divide by 2. We need to set this up, and it'll be here. So when is cosine -1/2? Cosine is 1/2 at 60 degrees. So I know it's going to be over 3. But when is it negative? And that's going to determine what I put on top. Cosine is negative in quadrants 2 and 3. So it's going to be 1 less. So 2/3, that's the quadrant 2 answer. And 1 more, 4/3. That's the quadrant 3 answer. And that is our 4 answers for this problem. So, ending of video 1, I hope that was a good review. How to solve a trig equation if you have one term, and how to solve a trig equation if you have multiple. The next video is going to be what to do if we have, say, a 4x or a 3x or a 2x. That's coming up next. So, stay tuned. How do I shut this thing off? Technology, man.